So far, we have met two ways of describing sets. By just making a list of all the elements, which works well for very small sets, or by showing the pattern and where it starts and stops. So, for example, 3, 6, 9, and so on up to 30 shows me all the multiples of 3 up to 30. But there are two major problems with this. First, what if the pattern is hard to see? What if it's not a pattern that's going to be obvious to the reader after looking at just a couple of elements? For example, if I gave you this pattern, it looks like I'm listing all the even numbers, right? But for some reason I left out 8 and 12 and then a whole bunch all the way up to 22. It's hard to see what the pattern is in this set. In fact, these are all of the numbers that I get by multiplying a prime number by 2. The other thing is, what if there are too many numbers to put into the list? Right? What if I want to list, for example, all the real numbers greater than 3? Then I want 4, 5, 6, and so on. But I also want all the numbers between 3 and 4, all the numbers between 4 and 5. In order to capture these two things, we introduce a new way of writing sets called set builder notation. The set builder notation looks like this. We start with a curly brace and we end with a curly brace. In between we have a vertical bar. Before the vertical bar, we have an expression with a variable in it. And after the vertical bar, we have the rules the variable must follow. So in our two examples here, these are all of the numbers that can be expressed as 2 times x, where x is prime. These are all the numbers that are greater than 3. I would read this as the set of all x such that x is greater than 3. I would read this set as the set of all 2x such that x is prime. When we have a set in set builder notation, there are two things that we might want to do with it. We might want to give an example of an element of that set, or we might want to decide whether a given number is an element of that set. So let me give you an example. Let's say that we have the set of all x over 2 such that x is an integer. To give an example element, first we'll pick an x that obeys the rule. The rule is that x must be an integer, so let's pick x equals -3. -3 is an integer. And then plug that value of x into the expression. If x is -3, then x over 2 is -3 over 2. -3 over 2 is an element of that set. Okay, To decide whether a given number is an element of the set, say we want to decide whether 5.5 is in this set. First, we write our number in the form before the bar. So in this case, we want to write x over 2 equals 5.5. We read x over 2 as 1/2 x. We'll multiply both sides by 2, and we get x equals 11. Okay, so 5.5 can be written as 11 over 2. Then, decide whether the x you found obeys the rule. In this case, we found x equals 11. 11 is in fact an integer, so yes, 5.5 is in the set. One thing to be aware of, in a lot of cases, the expression to the left of the bar will just be x by itself, which means that there may be no work at this step. There may be no work at this step. And you only need to decide whether the given value follows the